All right, properties of logarithms. This is probably probably the biggest thing that we spend a lot of time on are these properties. Now, in class, I'll prove them to you. Right now, I just want you to know the properties. See, what's happening is if you have a logarithm with two things being multiplied, it could be a number and a letter, variable, or it could be two variables. It doesn't matter. It could be three things, four things. If things are being multiplied inside the logarithm, you can split them up so that each of these things have their own logarithm. So I can say that I'm going to write it as log base b, it's still the same base, of m plus log base b of n. So if you see the plus, it means they were multiplied originally. Now you can also go the other way. If it was like this, you could put them back together into one logarithm being multiplied. Okay, another one is if they're being divided originally, so you see here I have them being divided, then they can each get their own, and we can say it's log base b of the first one, m, or the top one, minus log base b of n, the bottom one. Okay, so if you see a minus, that means originally they were divided. Now notice in the division it's just one logarithm, so if I was to put these back together, it would just be one logarithm, and then I'd have m over n, and I would take these two and just divide them. And then the last rule here is that if you have an exponent there, that exponent can go out in front. So I can put it as k times log base b of m. Okay, and so that exponent can be out in front. And once again, I'll prove these to you. Right now, we're just really worried about you knowing these. So how can we use these? There's a couple ways. One is, let's say I want you to write this in terms of natural log of 3 and natural log of 4. Now that looks really silly because right now we have natural log of 12. Well, I know if I look at 12 and I look at 3 and 4, I know that 3 times 4 is 12. So I have natural log of 3 times 4, which means natural log is the same thing as a log. It's just base e. So this means I can split it up into two separate ones, natural log of 3 plus the natural log of 4. And I've written it now as a natural log of 3 and the natural log of 4. Now, what about this bottom one where it says natural log of 16? Well, 3 has nothing to do with 16, but I do know that 4 squared gives me 16. And remember that rule that if we have an exponent, we can put that out in front. So now I have 2 times the natural log of 4, and technically I've written it as the natural log of 4. It's just got a times 2 in front. Okay, how else can we do this? Well, we have something called expand, which means take those rules and do everything that we need to do to them. Okay, so as I look at this, I see there's a lot going on. I have 2 times x squared times y divided by z cubed and b to the fourth. Okay, so the first thing I see if I look at the big picture is that this is being divided by this. And if you remember, division means minus. Okay, so I'm going to rewrite this as log base 3 of the top thing, minus another log base 3 of the bottom thing. Okay, they each get their own log. Okay, now I've got it out, and now if I look at the new problem, I've just got multiplications here, and I've got multiplications here. Now I have 3 multiplications here. This 2 is not connected to the x squared. It's its own multiplication. So I need to separate into 3 multiplications here. This is a big problem. So I've got log base 3 of 2 plus, because it's multiplied, log base 3 of x squared plus log base 3 of y. Then I've got a minus. Now I'm minusing all of this. So when I split this up, because I've got a multiplication there, I'm going to split up into a plus. Because I'm minusing all of it, I am going to put a parenthesis and do my plussing still, z cubed plus log base 3 of b to the fourth. But technically, this minus needs to be distributed to both of them. And so technically, they're both going to have a minus once I'm done here. And the last thing I need to do is take care of my exponents. Notice I have these exponents here. Okay, those need to go out in front. So now as I rewrite it, I'm going to write them out in front. So I have log base 3 of 2 plus, now I have a 2 log base 3 of x plus log base 3 of y. And then besides just moving the exponents in front, I'm going to also distribute my minus sign. So it'll be a minus 3 log base 3 of z minus 4 log base 3 of b. And the only other thing I want to point out is, I went through a long process right here where I did a minus and I did this big bubble and I did a minus and I did the bubble and then I have to go through and distribute. You can save yourself time because if you notice, z and b were both on the bottom and both the z and the b have a minus in front. So basically, if it's on the bottom, you're going to have a minus. If it's on the top, it's going to be a plus. Okay, so you can save yourself a little bit of time in writing with that. Okay, the other thing you can do with this is called condense. So the idea with condense is it's already written out as one logarithm. Now you want to put it back and make it just one log. So here they each have their own log. Now I want them all to be together in one logarithm. So the first thing I'm going to do is take care of my exponents. Unlike expand, the last thing you do is take care of exponents. On condense, the first thing you do is take care of exponents. So I'm going to rewrite it. So I have 1/2. I have log base 2 of x plus log base 2 of y cubed. So that went up, minus log base 2 of z to the 4th. That went up. Okay. Now you see that I have this big guy right here, right? That I'm going to take care of last. I'm going to put these together right now. Remember, if it's positive, it's on the top. If it's a minus, it goes on the bottom. Okay, so now I have 1/2. I have log base 2. I have x times y cubed because it was a plus, so I'm going to multiply. And now it's a minus, so the z to the 4th goes on bottom. And then the last thing I have is I have this 1/2 out in front, and that has to go up here to an exponent, but it's going to be an exponent for all of this. So I'm going to distribute that to all of them. So it's log squared, or sorry, log base 2, that was horrible. Log base 2, and it'll be x to the 1/2, y to the 3/2, over z to the 4/2, which is just 2 really. And that would be my answer because now I have it down into one logarithm with nothing in front. They all have their own little exponents. And that's pretty much it for these properties. So you're going to have to practice this a lot. This is something I really, really suggest you practice in order to know what you're doing.